Okay, good morning, folks. This was going to be the day before the midterm. But if you have checked your email, you'll see that last night, this morning actually, I sent everyone an email that the test tomorrow, the online test tomorrow, midterm test tomorrow, has been converted to a take-home test. Now, the content of that take-home test is going to be reviewed to you at 5 p.m. this afternoon. Okay? And you have until Wednesday, 12 noon, to have completed your work and upload it at 12 p.m., 12 noon, not 12 p.m., 12 noon, at 12 noon on Wednesday, the upload features in Blackboard are going to disappear, and you're not going to be able to put anything in it. Please read the attachment that I sent with the email. Read it carefully. This is critical because I will accept no excuses if things are not done by Wednesday, 12 noon. Computer down, access pad not working, CATIA not kicking me, letting me use it. This is all your problem. You have 115 hours to sort this out from 5 p.m. to this afternoon to 12 noon on Wednesday. Okay? If obviously, if everybody took the or you, let me make it you, decided to say, oh, I'm gonna do other things, I'll do other things, and then maybe Tuesday night I will work on the project or the problem. And if you don't get any licenses, you don't get in, that's your problem. Okay? Remember, this is 50% of your final grade. And if you don't do it, you're not gonna get that 50%. Okay? Thank you. Are there any questions? Are there any questions? Yes, can you speak up, please? If that question is for me, you have to speak up. Okay, there are no questions there. All right, so my plan today is to go through the remaining 3 problems on the second sample test that I sent you. Now, the first 2 problems were done for another section, and you don't have access to that recording because they are from section 53 and 54. You don't have access to that. However, that recording was also posted on YouTube. So in all likelihood, either you watched it on YouTube or you're going to watch it on YouTube. I have no plan of doing the first 2 problems again. Okay? So what we're going to do is the remaining 3 problems, and we go start here. The only question that I have, I just noticed that my, I don't think it was my microphone, my speaker was off. And technically, if my speaker is off, it has nothing to do with my mic. Did you hear the first couple of minutes that I talked about the take home and blah, blah, blah?
Yes, we heard it.
Okay, thank you very much. Thank you. Okay. All right, so let's go ahead and look at this problem. This is the second, this is, wait a minute, where is this? Oh yeah. This is the 3rd problem in that second sample test. When you look at this and read the description, of course, and if there is a problem like that, I will make sure to say that all components are perfectly welded, etc., or bonded or glued or welded. Oh, no, I'm sorry. Let me take it back. No. You look at a problem like this, you should realize that this is an assembly problem. And you should realize, because it says these pins are inserted, symmetrically, etc., this contact between these two is got to be the interaction between the pin and this bracket is going to be contact, not fastened. If I had told you that all components are perfectly welded, glued or bonded, then it would be fastened. There is no such mention of that here. And we have done problems like that. The wording was exactly the same, pretty much. And this problem was solved as an assembly where the connection between the pin and the bracket was contact. Okay. You cannot solve this problem as a single part. It must be done as assembly. Right up here it says an assembly. Now, the ends of the pins are clamped, and that top face, it says is subjected to a pressure of 10 psi. Now, use the most appropriate element. Obviously, it's going to be all solid. If somebody decides to solve it with shells and beams, I will look at it, but in all likelihood, you're doing it out of desperation, or you're so good that I have to mark that problem myself because I want to see what you have done. Okay? This problem, 99% of you are going to be doing it with solid elements because we have done things like this. Use all planes of symmetry. Now you look at this problem, stare at it, think about it, just don't impulsively say no plane of symmetry or 3 planes of symmetry or 2 planes of symmetry, etc., and come up with the answer. This has only 1 plane of symmetry. So you cut it into 2 pieces, left side, right side, and that is it. Now the choice is yours whether you want to create that cut part, or you can create the whole thing and then cut it with, in assembly design. That's entirely up to you. You know what? I will do it as, I'll make half of it. How about that? Okay. And this is it. So let's go ahead and do that. We're going to start with a product, right? Not part, product. Immediately, we're going to save that. File, save management, save as, desktop, new folder. I'll call it midterm. Midterm problem 4. I remember, yeah, so that's it. As far as the naming goes, you know what the convention is. You start with the ID number, your last name, any identifier such as problem 4, and save it. Okay? You can do that at the very end using that functionality that I showed you with the asterisk and thing in file save management, or you can just write it here and give it the name that you want. I'll leave these things to you now. You have done enough time, you know how it works. Okay. And please, if you don't know what I'm talking about, then there may be a few people. There may be a few people who don't know what I'm talking about. And let me give you a good example. I got an email yesterday from somebody saying that my access pad is not working because I am somewhere in the world. And even if it works, there is a lot of drag or a lot of lag on it. And I understand that. And because of that, I went and bought a license to CATIA, but it's a different license. It's a license, I don't know, some other license that is either higher than the one that we have at university or lower. The question that the guy had was, can I, and this is yesterday, right? This is yesterday. Can I do my work on that and send it as somehow, I don't know, email, whatever? So before responding to this guy, it occurred to me that, okay, this fellow has been doing something for the past 7 weeks or 6 weeks, let's say. So, and there was no complaint up to this point. So why is he asking me that question now? I mean, do whatever you were doing. If you're submitting homework, just do it exactly the same way. So I went and checked the grade book. 0 homework. No homework was submitted by this guy. Okay? So that is the kind of person who doesn't know what this thing is that I just mentioned to you. I said, we have a convention, and you have to follow that convention. I'm sure that guy has no clue. I don't know. So that's why I brought it up, because some people may not know after 7 weeks what I'm talking about. Here's a good example. Okay, let's make the bracket. Insert, new part, in there. And I'll call this thing bracket. How about that? Part 1. Properties, bracket. And bracket. To make it. Double click on it. Double click when I say double click on the second line in the bracket, okay? So that it sends you to either part design or takes you out of assembly design, sends you into part design or generative shape design. Well, since this is a 3-dimensional object, I'm going to switch to part design. I can do padding and things like that. Okay, so on that plane, I'm going to sketch. All right, that triangular black bracket, like this, like that, like this. Okay, let's put some dimensions here. Based on the dimensions that I showed you on the screen, this is 12. This guy is 6. There are 2 circles here. There are 2 holes here. So let me make the hole. I'm going to position them in just a minute. Another one. Put it here. Put it there. We're going to have to clean this up, right? So the distance from that center of that to this is, I believe, 1. The distance from the center to this line, it is also 1. Same 1. Okay. The distance from here to here is 1. Okay. And the distance from this center to that center is 2. And the radii, this is 0.5, diameter 1, radii 0.5. Same thing here. Diameter 1. Excellent. This is it. Exit. Now the total thickness is the problem statement says total thickness of 2. That's what the problem statement says, right there. So we're modeling half of it, and therefore we just pad it by 1 inch. Excellent. Now I want to save everything. The one thing I noticed is that if you look at this diagram, it looks like the scale, like this may be 3. Okay, in order to get something like that, this may have to be 3. But you do it as I gave the dimensions to you. In other words, if you look at this, it looks like these are closer together. So you go by the problem statement. Don't go by the shape that you see on the question sheet, because that may have been off by scaling and things like that. Okay, so this is what I gave you. That's what you do. Yeah. Okay, let's go up to the assembly level. Click on the floppy, and there we are. Let's insert the top pin. So insert, new pin, not the new part. I'll call it right-click, properties, top pin, and top pin. Double-click on it, make it. The fastest way of making this is project this and pad it by half the length of the pin. The length of the pin is 3, so we have pad by 1.5. So let's do this thing on, for example, on that vertical plane, the YZ plane. We're going to sketch. Instead of me sketching that, I'm going to project that circle right there, and exit, and pad it by 1.5. Okay, again, you can see that that thing does not match this kind of a scale, because it says the pin's 3 inches long. So I'm really sorry. I try not to do that, and I have not done it on the test. Okay. However, somebody may look at this and they may look at what they have done. They might say, wait a minute, something wrong here. Okay. And I agree with you. As I said, this was unfortunate that it was drawn like that on the paper, but you just go with the dimensions that are given to you. Okay. Okay. Good. Go all the way to the top. Save it. Now, instead of making that other pin down here, you may decide to use this. I don't think it's a good idea unless you know what you're doing. You can do copy paste. That's better. Or you can say insert existing component, and that's the one that you have to make sure you know what you're doing. It is not hard. It is just that when you insert an existing component, and for example you cut this pin, that pin is also going to get cut, and that may not have been the intention. I'm just letting you know. So this is a simple problem. Don't make your life harder than what it is these days. In a new part, call it bottom pin. Bottom pin. And this is the part instance name, and the part name is bottom pin. CATIA does not have part name. It has part number. I don't know. That's not what it is. Make it. Same routine. Double click on this. On that vertical plane, you sketch. So project that circle. Exit. And pad it by 1.5. 1.5. Okay, there we are. See this? All right. Go all the way to the top. Save everything. Apply material. Everything is made out of steel. Otherwise, you have to go through individual parts and change them. For example, if you may have a shrink fit problem, etc. That these are different. One is aluminum, one is bronze, etc. Then you have to apply it within the part. Within the part, apply this thing. I don't know, brass or that thing, whatever it is. But here, everything is made out of steel. So let's go make the whole thing out of steel and be done with it. Save. Now we're done there. Well, before I move on, are there any questions? I have 21 customers here, so okay. So let's go back. No questions. So you're going to go to generative structural analysis. CATIA sees 3 solid parts. Oops, wait a minute, what did I do? Generative structure analysis. CATIA sees 3 solid parts. Immediately it meshes them. In the absence of any instructions, leave things the way they are. This may be a bad idea. Sometimes your element may be so bad as far as the size goes that forever you may not run, then go and, for example, make it smaller. But if it's running with default stuff, just go ahead and use it, okay? All right. Yep, you can look at it if you want. See, terrible. Too fine. This is too coarse. This is too fine. This is a horrible mesh here on the side. Look, because it is too big for that circle diameter, whatever. The other thing is that you should be able, if asked, you should be able to refine the mesh around this hole, around that hole, etc. I'm not going to do that. We have done it several times, and I told you that I'm going to ask questions about on the midterm about refining things. Okay, good. Now deactivate this. If you want to deactivate, you can go here, right-click deactivate, or you can put it there, right-click deactivate, whatever is convenient for you. You can put it on the thing that you generate deactivated. Now, surface slider. These are symmetry planes, so we need one on that circle. We need one on that circle. We need one on the entire bracket. Because sometimes people put this thing and they don't realize that, hey, wait a minute, these are different. You got to do it also. And then you put a pressure of 10 psi. 10 psi. Okay. You're going to clamp these ends. And you create the connections. Connection between this face, second component, hide that, the hole. Oh, did I do the edge? Oh, I accidentally did the edge. Wait a minute. Double click on it. Yeah, this edge, I didn't mean the edge. You can just reselect it. It's gone. Select the hole. Yeah, face. And do another one. See, when these things, there's so many of them, then maybe you should label them properly. Top pin and the bracket. The next one, bottom pin and the bracket. But yeah. Oh yeah. I'm going to say something after I finish this thing. Remind me about what we're going to do after, well, starting on Monday. Yeah. Work doesn't stop because you got to take home. Okay. And this must be, it's a must contact. Okay. So face. Yep. That's contact. See how it puts this icon there? Don't fool around with these. You can fool around with it and get numbers, but the problem is that you don't know what you have done, and it's useless, as if you didn't know it. That's fine. If you want to know, let me know. And I'll refer you to the places that I'll teach you how it works. Okay? Not for this course. Where's this guy? There we are. Another contact. All right, let's save our analysis. File, save management, analysis, save as. I'll left it as analysis, but you have to call it your ID number, your last name, identifier, say problem 4, etc. And okay. All right, so let's run it. And let's hope that nothing goes wrong. You are familiar with this. Whenever you put surface sliders, you in almost all problems that we have done, you got this warning message. I don't know why, but Run it. Okay, look at the deformation. That's the way it should be. Another word. So if you animate, this was originally, let's look at the view from the front. Is that the front? Yep. Yep, you can see that you put the load here, it kind of tilted. You can see that. You animate it. That's the way it should be. The pins stay put because they're clamped at the ends, okay? And of course they deform and they interact with this, but they don't go up and down, at least at the ends where you clamp them, okay? And then you can look at your one Mises test if you want, total garbage. You just make it run and you look at the numbers. They look colorful, but they mean nothing. Zilch. Okay? All right, so that takes care of this problem. Are there any questions? Okay. If there are no questions, once again, I want to remind you. Now, this was written in the attachment to your email regarding the take-home. It was written there. There's a box at the very bottom of that attachment letter or note. It says, remember, if you're doing analysis of a part, you have to give us the part, cat part file, and the analysis file, cat analysis file. Both of them. Any one of them missing, you don't get the mark for that problem. If you're doing analysis of a product or an assembly, like what we're doing now, you have to give us the cat product file. You have to give us all cat part files that are in this problem. And in this problem, there are 3 parts. We need all 3 part files and the analysis file. Any one of them missing, we just lose the marks for this particular problem, which happens to be 40 marks on your test. It was 20 on this test because there were 5 problems. And they had 3 hours. And it was in class. And there was no YouTube videos. There was no Blackboard recordings. You came in for 3 hours, sat there behind the computer. The GAs were there, I was there, and you finish your work and go. Open notes and book, but nothing else. All right. There are no questions, so I'll move on with my next problem. Okay, where are we here? Right here. Second problem. So you have a geometry like that, and you read it carefully, see what it says. Now, it has happened, and it's bound to happen on the test, on the midterm, on this take-home midterm. People will send me an email saying that, oh, this doesn't say where it's fixed. It doesn't tell me what the load is. And we're not going to respond to that. The only comment that we're going to make is, it's on your paper. Spend the time to find it. That's why you have almost 5 days. Okay? Right here. It doesn't say it there. But if you don't look close enough, you might miss this. You might miss, some things. Make sure that the mesh around this hole is finer. But you have 115 hours to take care of these things. So please, you come to us and the GAs, we're going to tell you it's on the paper. If necessary, you can find it. You have eyesight problem, and some do. Honestly, some do, because these may be illegible, etc. Sometimes, yeah, you can zoom it. Carefully look at it. Okay. All right. All right. So the problem, you look at this. It's obvious that this is a part problem, and the most appropriate element to solve this problem, solid elements. Okay. The only thing that you can use for this problem. I mean, that's not quite true. Let me give you an example, because this problem can be solved with shell, where this vertical face is shell, horizontal face, top face is shell, and somehow they're connected together, and the thickness of that shell, I don't know, 1 inch, thickness of this shell is 2 inches, etc. Don't do it, please. Okay? For this problem, for these kind of problems, it is solid element. Now, okay, look, this problem, if you did it with shells, and if you can finish it, and you did not screw it up because you used something that you're not supposed to, I'll mark it, and I'll give you, even if it's done properly, full mark. I have no problem with that. But if you did shell and you could not finish the problem because that's what you did, you're not going to get the marks for it, okay? Or for certain part of it. Let me give you an example. It says, see here, it says, make sure that the mesh is fine around this hole. Okay, you know how to do it with solids, and you get the part mark for that, whatever it is, 4 marks, 5 marks, whatever. But if you did this thing with shell, I did not tell you how to do that. And unless you explored it yourself, you would not know how to do it. So you're going to miss that fine mesh around the hole if you did it with shell. So you're not going to get the marks for that. Okay, let's move on. This whole thing is something, what is the fixity here? Oh yeah, the inside face surface is clamped. Okay, the entire face is clamped. Please make sure you don't take the edge, meaning taking the edge, you lose the marks for that particular restraint that you had. Okay, and this is accelerating in that direction at some value. This is almost 3G, okay, because G in inch per second squared is about 340, so this is almost 3G. So we can think about this thing, something mounted on a car, and the car accelerates at 3G. It's impossible. Maybe an aircraft, maybe a fighter aircraft. But now, you have to use all planes of symmetry, and if you're using solid elements, and you should for this problem, then plane of symmetry is can you help me with this? Let me see, of the 22 people who were there, how many of you are sleeping? Would you like to answer that? Or describe the problem to you? And how many planes of symmetry I have? And what is the plane of symmetry in this problem? That's what I'm asking. Can you speak, please?
There would be one plane of symmetry, and it would go through like the longer length.
Yes, good, that's good. Okay, so again, we have here a choice of making it or making the part, or half of it, or the whole thing and then cut it. Let me, I don't know, I'll make the whole thing and cut it. How about that? I don't know why, but somehow I feel like doing it that way. Okay, so let's go ahead and we'll get to that later. Okay, a part. Okay, so on that plane, I'm going to sketch that inverted T. T. I'm going to clean it up. Good. So a bit of a cleanup here. Left line control, right line control, middle axis. Is it symmetric? Yep. Left line control, right line control, middle axis. Symmetric. You do it any way you want. Just make sure that the part is generated correct. Okay. And now we're going to put some dimensions here, and based on what I have on the drawing, this guy is 6 inches. Okay. Ooh, sometimes these are scary because you do things. Ah, oh, let me delete this. Let me delete this. I have to clean it up. I don't know why I ended up with that. Okay. To avoid issues like this, it is a good idea when you make this part, roughly you have those dimensions that you want, roughly, and then you clean it up. Because if you're totally oblivious to that, when you make it, put a dimension, it's too big or too small, it goes nuts, and then people panic. What was this? This was 2 inches. Okay, this height, this one is 1, I believe, obviously. Yeah, in the drawing it says 1. Oh, yeah, yeah. You see that? That line, control this line and make it symmetric, or make that thing 1 inch. Not symmetric, I didn't mean symmetric, coincident. There we are. I think this is what we want. So we exit, and we pad it by the full total length. Because remember, I said I'm going to cut it. Okay, so we have to be in part design. Pad total length is 11. What is it? 8. Right. Total length is 8. There we are. Oh yeah, you know what? Something, there's a dimension missing here. That's why it kind of looks odd. This thing is 10 inches. Yeah, this thing is 10 inches. That's why it's kind of fat. 10. Yeah. Exit. That's more like what I have in the drawing. So on that face, I will sketch my good old circle. And there are different ways you can do this. So let me, I'll clear it up. Okay. Okay. First of all, I want this point to be on that line. Control. Coincident. All right. I want this point to be exactly halfway between these two lines. So this line, control that line, control the center. We're going to make it equidistant. It's exactly halfway. Let's give it the dimension that we want to the circle. That circle looks like is 1. The radius is 1. Diameter is 2. Okay, and then we do a little bit of a cleanup here. For example, let me close this up. Let me delete this. Trim it. Quick trim it. As I said, you do it any way you want. Just give us this part. That's all. Right there, and then pocket all the way to the end. Very good. And this is it. This is made out of steel, metal. That is metal, steel on that part. You say okay. Let's save it. File. Save management. Something that I neglected to do, and it's a bad idea. I don't want to screw this up. Oops. Where did I put it? Oh, what was the name? Oh yeah, midterm problem 4. Oh, I'm not going to call it problem 4. New folder, midterm problem 5. Wait a minute. This was problem 4. Okay, I'll call it midterm. Midterm. Screwed up. my naming and numbering, and these are, you know, you don't think about these things, and then at the end you get confused like I did now. This should have been problem 3, probably. Okay, yeah. Good. Now we're going to go to generative structure analysis. Oh, what did I do? Not cut. Oh my God. Not cut it. I forgot to cut it. Let's split it. Split it with that. It doesn't matter which side you pick. Now you save. And now we're going to go to generative structure analysis. Okay, so what do we have? This bottom. Well, it says that I want to find a mesh here. You know how to do that. So you go to Model Manager. Second icon on the left. This is where you define local mesh size. Something like that. Look at this. Look at this. Bad idea, because you may sit there for a long time. Okay, that's a little bit smaller. How about that? Maybe 0.1. That's fine. Right-click mesh visualization. Okay, yeah, it's good. Deactivate. Clamp it. The bottom is clamped. Okay, and this entire thing is subjected to an acceleration of whatever in this direction x. So where is the acceleration? This is linear acceleration on the part in the direction x. If you want to go to the left or to the right, that's up to you. So 1,000. I think it says 1,000, yeah, in the direction x. And this is 0. Okay, it's accelerating this way. If you don't like it, just put a minus sign so that it goes like that. It's up to you. This problem doesn't matter. So, and on the test, it doesn't matter. But my suggestion is try to do it exactly like what it says. Because sometimes it does, and in this case, it doesn't. There. Save it. This is the analysis, right? And it goes to the screw up folder. Good. And run it. And lose your 6, 7 marks. And why would I lose 6, 7 marks?
I think
It
you
looks
got
good.
the surface slider.
Yes. Deactivate. Put surface slider. Right here. Once again, for those of you who want to be a bit more than just do surface slider, remember, surface slider is nothing. All it says is that no displacement perpendicular to that face. And although you could have said no displacement in direction x, I would have done exactly the same thing. That's it. As soon as I put the surface slider, I got that warning message, remember? Yeah, this is it. I mean, it looked the same, but what you did was not right, okay? And notice that it goes tilted back and forth. The reason is that yesterday or last time that I was working with one of you guys, I did some thing here. You see under animate, you can do it. Click on this, it goes in one direction, it goes back and forth. So if you click on this, it goes only in one direction. See that? It's up to you which one you like. We don't care. This only goes in one direction. Okay. Or at least it should have. I don't know. Yeah, play with it. It'll work. Now, last problem. So I assume that there are no questions. If there are, please let me know.
Professor, I actually have one question about that.
Yes.
Could you just explain real quick why, with this particular problem, when there's an acceleration, why there's one plane of symmetry?
Okay, so let me bring this up. Actually, let's go back here. All right. Now, let me put it this way. Suppose that, remember, a planar symmetry means that if you look at that plane that you're talking about, whatever it is, obviously before any deformation takes place, it's a flat surface. Do you agree? I mean, a plane is a flat surface. Do you agree? You agree with that?
Yep.
Yeah, okay. If that plane, if you took, for example, the vertical plane also as a plane of symmetry, and I think that's what you're trying to find out, why is the vertical one not the plane of symmetry? Imagine that this guy is accelerating. Wouldn't the structure bend? And that plane, vertical plane of symmetry, the one that you are concerned about, this one, actually is no longer a plane. It becomes a curved surface, right? It becomes like that. But the one that we took, when this accelerates, doesn't go to the left, doesn't go to the right, it will stay a plane. A flat surface, this flat surface that I took, remains a flat surface, okay? But if you took the vertical one like that you are probably concerned about, that no longer stays as a plane. It bends and it becomes a curved surface. If this was accelerating up, then that would be also a plane of symmetry. But not this way or that way, etc. Does that make sense?
Yeah, thank you very much.
Okay, no problem. All right, let's go to our last problem. I don't know, you may have even done this, I'm not sure, but if not, we're going to do that. This problem, see, it says ordinarily, this was, and I added this not on the test, but this, I did it for you guys. Ordinarily, I will not tell what kind of element should be used. You must make the decision yourself. In this particular problem, however, I'm asking you to use the beam elements, okay? The reason is that I drew this thing fat. You know, somebody might say, well, look at this thing. I mean, it's fat. It looks like a solid. I can do it with solid. Yes, you can do it with solid elements. However, I'm telling you to do it with beam elements. If I had made this cross-section smaller, you will not be able to see it that well, and you know, then you say, oh, I can see that's a beam. It's a very slender member. But even this fat thingy should be done with beam elements. Okay, so we have some dimensions here, 6 and 3 and whatever. These ends are clamped. And you're applying a force in the middle. Actually, I'm making it displacement in the middle. 0.01 inch. Is that what it is? Yeah, it's a force is applied right in the middle, so that it moves down by 0.01 inch. Now, beam elements, obviously here I told you, and for symmetry, if you look at this problem, for symmetry, you have one plane of symmetry, and that is just making half of this, half of that. Don't do the other half. Doesn't matter which one. Now, and then you can solve the problem quite easily. If you tried to do it without a plane of symmetry, you said, it's too much work. I'm not going to do it. I guarantee you, you can't finish the problem. I guarantee you. In this problem, if you do plane of symmetry, you can easily do it because we have discussed it over and over and over. If you don't do it, I guarantee you that you will not be able to solve it with beam elements because you don't know how. Try it if you want. Try it. Okay. All right. So let's go ahead and make these things 3, 6, and radius 0.5. Let's quickly go ahead and do this part. And okay. So let's make that thingy. So on that plane, sketch. You know what? I keep saying I guarantee you. I hope that somebody can do it, but it's not that it's not doable. It's just that most of you will not be able to do that. All those people who can do it with full planar symmetry, of course, they lose their marks. There's no doubt about it. Okay, they lose the mark for planar symmetry, but at least they must have done some additional reading or doing things. All right, so that takes care of this. Let me put some dimensions here. I don't know, this hang in there. I can't. Let's see now. 6. Okay, so that is not 6 and 0.5, right? Okay, so here's what I'm going to do. So this thing is going to be 5.5. No, 5.5. Yeah. If you're doing it like this is going to be 5.5. This radius is going to be 0.5. And this is going to be 2.5. If I'm doing it like this. Exit. Okay. Can you help me? What I have to do next? If I'm doing it like this, what is it that I need to do next? Yes, can you please say it?
You need to join them.
Yes, yeah. Otherwise, you won't, because you did it as a sketch, you won't be able to mesh it, etc. And to join, you go to Generative Shape Design. If you did it as a wireframe, there won't be an issue, but there we are. Good. And we apply our material on that. It was made out of steel, metal, steel. Okay. We're going to save it, file, and because the cross section is, by the way, a circle, I don't need an orientation point and like that. Save management, save as. This is going to be problem 5. Okay, so up, new folder, midterm problem 5. Problem 5. We say okay. All right, no problem. Do it again. All right. So we're going to go to generative structure analysis. And we're going to mesh it with beam elements. First I have to, beam elements, right there. See this, beam? And I can select it because I joined it. Okay, I'll make 0.3 here, 0.4, something like that. I'll make it 0.2. Beam elements are very robust. You don't need that many of them. Okay, section. This cylindrical, and what is the radius? So this is from last time I used the software. Okay, so I better go read this thing what it says. Cross section is, as I said, for your midterm, for the take-home midterm, it's there. Read it. Diameter of the cross section is 1. It may be here, it may be in the drawing. Here, circular cross section, diameter 1. So don't please send us emails, say, what, you didn't give us this, the dimension. Okay, it's there. Because your test has been proofread several times. All right, so 0.5. Okay, that's why it's so fat. You can see that. You can close it. Now this end is clamped. That end is clamped. Okay. This point is in a plane of symmetry YZ. So it does not move in X. Let me uncheck all of these. That point is in the YZ plane of symmetry. It does not move in X. Translation 1. This is global, right? Rotation's opposite. And this point. Okay, very good. Now I want to push it down. To push it down, it's a good idea to put another restraint here, a separate one. Say again this point. But I want to push it down, so I make it 0 first. This is 0 in the direction Z. And now I can go and change that. So enforce displacement. If you can pick it from the screen, go ahead. If not, go and pick it from the tree. The strain. See, this is the one is for pushing down. In fact, if you select it, you see that this lights up. This vertical one lights up. And it was minus 0.01. I think it was 0.01 inch. Was it? Push it down 0.01 inch, yeah. Do not divide this thing by 2 because you're taking half of it. Believe me, some people will do. Okay, so let's save the analysis, file, save management, the analysis, save as. In that folder, midterm problem 5. And run it. Nothing unusual is going to happen. This is going to bend downward as you expect. And I'll show you something here for a second. When you look at from the front, the angle should be 0 angle created when you look at the front. So, but first of all, let me animate this thing for you. Animate it. And if you look at this thing from the front, you see this angle stays 0. And if you don't believe it, that's because your element size is a little bit big. If I made smaller element sizes, you see it comes in at 90 degrees, like this. It comes in like that because it has to be symmetric. And that's what symmetry does. That symmetry condition makes sure that this comes in horizontally and then goes horizontally at the other side. All right, so as far as today is concerned, obviously we have a lab till 11:20. Now I made my portion. There is no homework. We will be around here. I have to go to my other lecture in an hour, but the GAs are going to be here, and then I have an office hour at 11:30 to 1:30, you know, etc. Now, just to let you know that on Monday, I think some of you said that once you write your midterm test, if it was tomorrow, you're going to burn your notes because the rest of the stuff has nothing to do with what you did in the last 7 weeks. Okay, don't burn it yet. You have to wait until Wednesday, I suppose. But anyway, the life doesn't stop because you're writing a take-home test. Okay, so I will start the new subject, and I caution you that if you think that the last 6-7 weeks was fast, this was going to be faster. And there's a lot more little bits and things in it. It has nothing to do with finite elements. So these are, of course, posted, but usually people get bogged down with other courses and other tests, and they don't watch these. And then in 2 weeks' time, they realize, oh my God, I have no clue what this guy did. And then the final exam is going to be in class because we're planning to do some major changes in the licensing and the number of licenses and things like that. So don't get the impression the final exam is going to be take home and you're going to have 5 days to work on it, 3 days to work on it. It's going to be in class, fast-paced course. You missed half of it, you're in serious trouble. Only 40% trouble. Okay, final exam is 40%. All right, folks, are there any questions before I stop the recording of this?